is occasionally they stream one of the keynotes for that live on the internet if you're interested. They don't stream the actual sessions, but depending on what kind of mood the people who are doing the AV stuff are in, they'll stream the keynotes. And then Twitter. If you follow any PHP people on Twitter, you'll probably only see ZenCon hashtags next week from them, because that's what everybody's going to be talking about. All right, so tonight, Redis. So, wanted to cover Redis. I love Redis. It's one of the coolest pieces of tech that I've gotten my hands on in a while. So we're going to talk about Redis and hopefully more about PHP and Redis than just Redis in general. So, for those of you guys that don't know me, I'm Director of Development at Redis in Austin. We own a bunch of websites that help people save money. We own offers.com, couponcodes.com, dailydeals.com, subscription.com. These are all websites where you get discounts on stuff. So that's what we do, and that's a great place to be in this economy, if you will. So the slides and any of the code that I'm working with is on GitHub. My GitHub ID is JumboJSB, and that's me on Twitter as well. So we're going to look at actually what is Redis, what does it do. Redis is a database that has lots of different components that are built into the database. It's closer to something like MySQL than it is to something like Memcache. It's got actual features. So we're going to look at all the different kinds of things you can do with it, and then just kind of got some Cookbook-style stuff to do with it with PHP that we've actually done at offers.com to help us improve performance. So at heart, Redis is a key value store. It runs, it's in memory, you stick data into it and you get it back out. And you give the data a key and you put stuff in the bucket. If you've ever used Memcache or something similar like that, if you don't really care about anything else, it does that. So it's a little bit better. A lot of its commands are atomic, which really helps you if you're trying to actually make sure that your data is saved one after the other. If you got a lot of clients connecting, you get a little bit more integrity there. The real magic is in server-side data structures. So you can have different kinds of keys, just like you can have different kinds of columns in MySQL or any other sort of relational database. So you can actually a little bit closer maybe model what it is that you're trying to store in this key value database with the different types of keys, as opposed to having to do all of that in write code for that, because you just have a plain old bucket you can shove something into. And that's kind of the Memcache way. The other nice thing, it has disk persistence. It has to be in memory, right? Redis does have a couple different features you can turn on that will, like, what if I run out of memory? But actually those are going away. Those have been in there for a while, and they have kind of a virtual memory system, but that's being taken out. They kind of decided to focus on, this is an in-memory tool. We're going to write it to disk so that if your server crashes, you can bring it back up and have all your stuff back in memory again. But you need to have, if you have 32 gigs of data, you need 32 gigs of RAM to do this. So interesting things that it doesn't do. Like I said, it has disk persistence and it has journaling, like bin logs, like MySQL does. But I wouldn't put my most treasured transactional data that I'm out of business if I lose it. We put in stuff where you can say, like, yes, the website will not work unless Redis is running and this data is in there. But I don't put anything in Redis that I couldn't regenerate from a relational database if I needed to in a pinch. It's not really a document database. You kind of see it listed off with other NoSQL databases, and you'll see it next to MongoDB and Couch and things like that, because it's more of a database than just a key value store. But it's not a document database. And so it's kind of confusing, because a lot of times when you see like Google list of NoSQL databases, you'll see it in there, but it's kind of compared against things that doesn't really make sense to compare it to. The other thing is it's not multi-threaded. You think of like MySQL, and it's heavily threaded. That's the way it works. Redis is one process, and it's one thread. So if you exceed what that can do, you need another Redis. you need another process running on a different port. Now, that said, it can do a lot. You know, we do millions and millions of page views a month that have not even come close to touching what it can do. But ultimately, you know, if you exceed what one process can handle as far as file handles and TCP/IP connections and that sort of thing, you need another one. And there's, you know, the documentation tells you that's how you do it, and that's how you grow this thing as you shard it and you have more of them running. So how do you get it?
Question?
Yeah.
Sounds like you're describing something that's headed towards web services.
Potentially. In fact, some of the stuff that you can do with it is actually really nice for that kind of thing, for that kind of that model of connecting and getting data back and forth.
Yeah.
They have a lot of the built-in commands that lend themselves to doing service layer or SOA sort of architecture with it, you know, or job queuing, things like that, where different things are putting stuff in and different things are pulling stuff off the other end of it. I've actually got some code for that as well. So their website, Redis.io, it's an open source project. There's one lead guy on it. He's been the lead guy on it for forever. It's his baby. He's paid full-time by VMware to build this. I don't really know what VMware is planning to do with it, but VMware basically hired him and they pay him to do nothing but build Redis full-time. So it's open source, but it's actually got some money behind it, so it's being actively developed. It doesn't run on Windows very well. There's some people out there who have ported it to Windows and compiled it with Visual C++ and etc. But those aren't officially supported by the project, and they generally have little bugs in them that, you know, like, yep, that's a bug, it doesn't support it on Windows, sorry. So you want to be on a Mac, you want to be on Linux, BSD, that sort of stuff. One of the neat things about it is you're going to probably, you know, if you have a, you know, older distribution of Linux or something that doesn't have a package for it, Ubuntu has a package for it. If you're on, let's just say you're on CentOS or Red Hat Enterprise, and it doesn't have a package for it. When you go get the source code, you're not in this hell of like, I've got to get all these dependencies and install their packages, and then what version do I have? You pretty much can download the source code and compile it and you're ready to go in like 2 steps. It's mostly just C and C++. It doesn't have a lot of external things besides you need a C compiler, which is pretty nice. And it takes like, you know, 2 seconds to untar it, compile it, and run it. You're ready to go. There's lots, you know, you want to be running 2.0 or above. I know the Ubuntu package for 10.04 is not 2.0. I don't think you have to get like the updated port for that. 2.0 has a lot of nice features, especially the disk persistence is a lot more reliable in 2.0. I'm actually running 2.2, which is the most recent version. So on a Mac, Homebrew package manager is really a nice way to get it. Again, most people, you're going to put this on a web server somewhere, get your IT guy to compile it from source code and set it up for you. So, unfortunately, there's not really any good GUI tools out there. There's one called Redbottle. It's a Python app. My company's tried to write one unsuccessfully. There's a .NET one out there that has a bunch of ridiculous .NET dependencies. It's really hard to get running. In reality, it's the command line. If you want to browse what's in your Redis database, you're going to use the command line. And this is not really like, you're not going to write queries per se. You're looking at what's in a specific little slot, you know, little bucket key in your database. So it's not like you're going to look at 10 million of these things at once. So the command line is good enough. And it's got a nice command line tool. So how do you store stuff in here? Redis has databases, just like a database server has different databases. You know, we'll do like a different database per domain name that's connecting to the different application that's connecting to it. You can have thousands of databases if you've got the hardware to support it. The interesting thing is it's all one file. So like the disk persistence that backs it, if you have 1,000 databases, it stores the back end of that in one big database file. So it's not like you create a database and it puts a new file in a folder. Good and bad. The bad is that it's one gigantic black hole, and if something goes wrong in this one, maybe the other one's broken too. But if you want to back it up, it's just one file. You'll usually see people do namespacing when they create keys in here. So when you name your key, you're going to put a colon to kind of give it a little bit more detail. That doesn't actually mean anything to Redis, but just when you see it out there, you see examples of it. People are using colons to separate out different types of keys, if you will. Keys about for us it's keys about offers or keys about stores, different types of information. But that doesn't actually mean anything to Redis.
Is there even just a practice or a convention around that at all, or is it just whatever goes?
It's really whatever goes. What we've seen, what other people are doing, and what we do is like, if we want to take something out of a relational database, a row in a database, and store data about it in Redis for quicker access, we'll do like offer colon the ID of that row in the database, and then maybe offer types or shipping options or something like that. So we always include if it's something that came from a relational database, we always include in the key name the ID that it corresponds to in the relational database. Like I said, in case you need to go back and get it again.
So it's still related.
Yeah, so it's still related. So let's talk about keys. There's lots of different kinds of keys in Redis. String keys that's memcache, right? You have a name and you have a value. That's pretty much it. There's nothing special here. There's lots of different commands, and I'm going to show you the kind of Redis command page in just a second. I'm actually going to play with these keys in the command line tool. But so, at the very low level of this is a key value store, there's keys and there's values, right? That's the basic feature set. One of the other nice things it has is hashes. So you can store, like, if you're coming from PHP, kind of an associative array, you can store that as an actual data structure in Redis, right? So you have a name for your key, and then you can have other fields with values in there. So you can have a whole set of those. You can't nest them, but it is nice to be able to kind of give your stuff a label if you have a lot of kind of pieces of metadata that you want to store. And you don't have to actually write code to take like a PHP array, serialize it, and then store that in the value. You can actually look at these things in native text on the command line tool and see the different pieces that are right in there. And it stores those very efficiently. And you can actually work with the different values. You can increment them and change them and see if they exist. And the nice thing about working with even these complex data structures is most of them are constant time read and write even to these subfields here. Worst case, it's usually login time to operate on one of these things, which is pretty decent, especially when you're talking about a set of data. So if I want to go find out if my offer has free shipping, for example, I can go jump in here and see if it has a free shipping field, and that's it's so fast it's basically free. Whereas if I needed to go query a huge attribute table in MySQL, the more offers I have, the slower that gets, right? So pretty much everything that's not a string key is some sort of list, right? It's a hash which has got named fields and values for it. So sets are basically just like a one-dimensional array, right? It doesn't really have an order per se. So things you can do with it, you can put things into a set. You can see if things are in a set. Does a set have this number to it? It doesn't, you see it in an order when you print it out on screen, but it doesn't really have any implied order to it as far as Redis is concerned. So again, all of these commands you do here, putting something in a set is, n times. So if you have to put 10 keys in a set, it takes the same amount of time to put, each key in, no matter how many keys you have, up to like 4 billion. Is kind of the recommended maximum things to put in a set. So 4 billion things in there and you're good. 4 billion, whatever an unsigned integer comes out to be, a little over 4 billion. So lists do have order. So this is nice if you actually care what order you put them in and what order they come out in. This is more like your kind of queuing structure, right? So you can put things into the list on one end, take them off that end, put things into the other end, cycle through them. So it's built on the database side to do that. So you don't actually have to, pull it back into PHP and then take something out of the list and then push that data back to Redis. You can tell the database server just to do that and it will do it for you on the server side. Now you can obviously get the thing out. You want to take something off the end and have it in your hand, sure. But if you don't really care, you just want to shorten it, you don't actually have to write application code to go do that like you would with kind of a generic key value store. The other nice thing about this one is the commands to take things off the end. You can block with them, which means you can, if there's nothing left in there, you can wait on that connection until there is something. This lets you build job queues. That's the really nice thing about it is, so like if there's a million things in your list and you're writing code to go through those million things and do something with them and you're done, you've taken everything out and you're waiting for something else over here, someone to log into your website and put something new in the list, you can actually sit and wait for that list to have something else in it, which is really nice because that way you don't have to have a cron tab, if you will, a cron job to come back and check and see if there's something in there. Your code can just sit there and wait infinitely until something shows up.
So, question. So this is like first in, first out queue?
So you can actually operate on both ends, so you can do it either way you like. So you can put things in on the left-hand side, your right-hand side, and take them off that side, so you can work on both ends. So you can have last in, first out, however you like. And you can, that's really just talking to Redis from PHP, so you can change your mind midstream if you need to. So the last one, and this is really kind of like the complicated one, but it's where all the power is you can put them in and have them sorted. So you can have a list, a set. You have a list of things, and you can give it a score that you get to pick. It's an integer. But the neat thing about it is when you put them in there, it keeps it sorted. So when you take it out, if you ask for a range of things, like give me everything in my sorted set between 7 and 12, it basically already knows where 7 and 12 are on there. It's not like it has to go get the whole set, order them, give you that subset that you asked for, which is essentially what a relational database is doing when you execute that same command. It's going to order the whole set and then give you the slice. These are stored, ordered by definition, so it's really, really wicked fast if you want to get a slice of things by that score. And you get to pick the score. One of the things that we do with it is we use timestamps as the score. And so if you want to get the top 10 most recent things, it's really, really fast. And you don't have to care that there's 10 million things because it already knows what the most recent are. That's how they're stored in memory.
How's it different than like indexing in, say, MySQL?
It's not per se. So like, the thing is that this is one set of things. So if you're indexing a column in MySQL, you may have like 5 different indexes on that table for the different ways you may want to sort it. This is kind of somewhat more limiting than that because you're kind of agreeing up front that this is how I'm going to order this set. So you do get, it is going to be faster than querying an indexed table in MySQL, but you are agreeing that I wrote my code, so I want to get these out in this order very specifically. So upfront planning gets you a little bit more speed, but a little bit less flexibility.
It's a little bit like, not in MySQL, but Microsoft, what's the Microsoft SQL? A clustered index, which physically orders the rows.
Yes. Or, essentially, if you have a MySQL table that's pristine and has never had anything but inserts into primary key in that particular order, right? Yes.
Okay.
Very similar. And in fact, if you go look at the source code for, you'll never get clustered index source code from Microsoft, but the algorithm it's using to do that, there's only one way to do that. They all do it the same way.
Right.
So, that's kind of Redis in general. That's the overview, right? So none of this really makes any sense. You're like, that's great. Someone wrote a database server, there's already database servers. So we'll actually look now at how do we do stuff with PHP with this. So there's a whole bunch of libraries out there. There's a native C PHP extension that you could get from the PECO repository. It's not very good. Rediska is the one that we have been using for a long time. It's a Russian thing. Rediska means radish in Russian, I believe. So they've got a nice little website. It works great with PHP 5.2 and above. And they have a really nice integration with Zen Framework. If you're using Zen Framework, They have an application resource where you can just use your configuration file and tell it, the different Redis things, and it bootstraps it and makes it available to you. Plugs right in. It's Zen Framework 1.x friendly, and it's namespaced out to go right into your Zen Framework project. It's not the best code in the world, but it's got all the features that you want. They keep it up to date. The one that we switched to that actually is really slick is Redis. That's on GitHub. Redis is on GitHub as well, but they actually have a website outside of that. Redis requires 5.3, but the implementation there is a lot more the PHP way of doing things. They really take advantage of a lot of PHP's magic methods and closures and etc. to really do a better job of modeling Redis's data structures and way of life into PHP. Whereas Rediska is a little bit more kind of the obvious way you might write the client, where they really put a lot of nice thought into Redis as far as the design of that software goes. And Redis you can get as a FAR now, so you can just drop one file into your project and load that up, which is convenient, so you don't have to check out all the different files that go with it. So, actual things we can do with this. So one of the things that we do all the time is I have a product management department, and they love to do things like, if this offer has this little piece of data, do this special thing to it, because that would make people want to buy it. They love it. And I've got my developers sitting there screaming at me, we can't do that, we can't run that many database queries to generate a web page, it'll crush us, right? So this is one of the things, this is one of the first problems that we started solving with Redis. This isn't actually what our database schema looks like, but it's a similar problem. This is sort of an EAV style schema where you've got a database table, and it's got things in it, right? I have items. So I have an item, item's got an ID, and it's got a name, right? This is my basic stuff about my item. Every item has these things. Let's say I've got 10,000 items. I've also got items attributes, right? So this gives me kind of like schemaless data structure in MySQL, right? Because I don't know how many attributes any item might have, or whether it has them or not. Some of them may have 5, some of them may have none, some of them may have 30. So I can give it, the ID of my item and what kind of attribute is it and what's the value. So an offer may have, let's just say, has a name, and then a third of my offers have free shipping, and 20 of them out of 18,000 have a manufacturer's rebate and things like that, right? Things you might want to know about it. This could work with any sort of widget. So the problem is, product manager comes in and says, I've got the needle mover. I've got the next best thing that will make the company money, right? This isn't good enough. We need to say free shipping right here where they click buy, right? So we're like, okay, well, that's great. This is easy because this is an editor. Someone typed this into a text field, right? That's not really something I can scan. I can't query, a database and see if the word free shipping appears anywhere in any of the forms. So somewhere they checked a checkbox that was like free shipping, yes or no, right? So that got an attribute in the attributes table. It was like, this ID has free shipping. That's wonderful if I'm looking at one offer on a page, because I can go and get all the data about that offer and do whatever I want. These I do 50 at a time on a page, right? So I can do one of two things with MySQL. I can go and do some massive self-joining query where I get all the possible attributes and I bring them out of the attributes table and kind of pivot them up into virtual columns, and I can do that. But every time I want to add a new piece of logic, it gets harder and harder and slower and slower. So what we're actually doing is denormalizing some of this metadata about products into Redis. Because when Redis, I go ask it, Redis, does this thing exist? Remember, that's constant time. Doesn't matter how many keys I put in there, it's constant time for me to ask Redis, does this thing exist? And when I say constant time, not only is it programmatically fast, Redis is also really fast itself. It's in memory. I can do thousands of these on a page and never even notice that I'm looking up whether it has free shipping or not. So here's the old way, right? Here is hey intern, go implement free shipping attribute on the page, right? So they're like, oh, well, let's just generalize this and make it find any attribute just in case we want to do the next thing, right? So we've got code here that says, does this item have an attribute? And you give it the name of the attribute, and it goes and looks it up. Not particularly enlightened code here. It just goes and selects from that database, and we're just selecting one because we don't really care what the value of it is. We just want to know if it has it or not. This is somewhat pseudocode. It doesn't actually, there may be typos. The general idea is, get a PDO database connection, execute this SQL statement, tell me if it came back with anything or not. Does this offer have free shipping? So I've got a big array of items. I've got 50 of them on the page. Every time I call has free shipping or has attribute free shipping, it's going to go execute this database query. And in the blink of an eye, my page that had 2 database queries on it now has 52, right? And then the next thing comes up and now it has 102, right? So these start multiplying really quickly. And the more offers I have, the slower this gets. So how do we fix this? Maybe a little small. Same has attribute, right? So we're going to go to Redis and we're going to say, basically the way Redis works as a client, it gives you an object back, and all of the Redis commands, which we'll play with in just a second, are magic methods on it. So it just takes every Redis command that could exist and turns it into a magic method with PHP. So one of the ones is this S's member, which is give me a string and a key name and I'll tell you if it's in that set, right? So now we can say, and this is where my convention of naming my keys, right? My key name is item colon my ID number, which could be 47 or something like that. And then attributes. So that's the name of my key. So in Redis, I have a key, and that's a set. It's a big list of all the attributes that this offer has, right? And I'm going to go ask it, does it have the free shipping attribute? And the difference between Redis and a relational database is that is, no matter how many you have, takes the same amount of time. And it's also really fast because it's guaranteed to be in memory. So the one thing that I had to do to make this work is I had to go in, when I add an attribute to my items, go do the stuff you normally see, take it, write a SQL query, insert that into the attributes table, make sure everything's kosher. And then I'm going to go into Redis and I'm going to add something to that set, right? So sadd is how you add something. So basically, not only do I put it in MySQL, I just stick it in Redis. And this doesn't take any time at all. It takes, milliseconds to go do that. And it's only one line of code, not a lot to extra maintain, but this is, could be hundreds of milliseconds on a page load if I have to do this 50, 100 times, right? Does that make sense? So basically, a lot of what we're doing with this is taking data that would be in MySQL or some other relational database and denormalizing it into memory in Redis. And since Redis is fairly reliable, we can trust, for the most part, that this is going to be available to us. I'm reasonably confident that if I put something in Redis, it's going to stay there. And that I can trust that I can rely on that data to do my business logic. So let's actually take a look at what these sets look like in Redis.
Do you write to Redis in every case where you're doing any content management?
Not every case, but the ones where we're trying to optimize for. So we don't mirror every single thing, but the places where we're trying to use that to optimize our performance, yeah. A lot of times what we'll do is not necessarily in the content management tool, but when we publish content from one server to the other or push it live, that's where we'll do that step of copy it into Redis. Some things we do run at midnight, and they run at midnight and just kind of go do a bunch of data processing and clear out the expired stuff and pull in the new stuff and populate it into Redis. So we have it hooked in a lot of different places, but we don't, as a rule, do it in our content management system.
But the writes are fast and it's fine to do it.
Yeah, it's usually an order of magnitude faster to write it into Redis than it is to put it into MySQL with our table sizes. So I've got my Redis command line client here. Redis CLI like we saw on the slide there. It tells me what host I'm connected to. You can connect to other hosts remotely if you need to. So let's let's do that task we were doing there. So we can let's pull. Let's go. So Redis.io, right? Redis has commands just like MySQL has commands or SQL has commands. So basically, they have this giant grid here of all the different things you can do with it, and they generally are. They're prefixed with like the all the S ones start with S, smove, spop. All the hash ones start with H. So you can take a look at these, and basically once they all have set and get, right? That's kind of the basic one, and then they have different things that make sense for different types of keys. So and Redis CLI has help. You could say like help. It has all the stuff that you really want to know in there. The neat thing that I really like, because when we're doing Redis, we're trying to optimize for performance. When I come in here and say, I look at this, it tells me the time complexity of these things, right? So I really find that useful. If I'm trying to make this as fast as I can, that's why I'm going the extra mile here, to make sure that I actually am doing something intelligent here, and I haven't inadvertently done something that's going to be just as slow or slower. They've got pretty good documentation. They've got the related stuff, the return values. They've got some examples of how to do it on the command line. So let's create a set. So if we create a set that looks like, all you have to do to create a set is just add something to it. So we can do sadd, which is add something to a set. We'll call the set foo, and we'll call the value for one of the things we want to add to it is bar. Or we won't do that.
Just a bracket of set or something.
So here's existing ones, right? These are my free shipping ones. These are actual offers.com data. So let's pull up this guy right here. So one of the other ones is members, which is what are the things in my set. I'm going to pull up this guy. Right? So all I've really got in here is offer type IDs, right? This isn't particularly relevant to someone who doesn't understand how offers.com works, but this means I can not have to go look up if it has this ID in subjoined table somewhere. So again, this has two things in it, and I've pulled this out of a relational database. This could be thousands if you needed it to be, with no real penalty of any sort. So what we're actually just look at the, and we didn't actually stop to look at what a regular old key value one looks like. So we can do a set, right? That's your plain old stick something into it and get something back out. And you'll see like Rediska is actually really nice if you, and Redis as well, if you try and take some sort of complex PHP data structure and stick it in there, it will serialize it as best it can so that it puts serialized PHP in, and then when you call it back out, it's doing that conversion to get it back into PHP for you. But we usually just operate on plain old strings. We try not to stuff something too complicated in there because one of the nice things that we do with this is that it's really easy to talk to Redis from Java and Ruby and PHP. So a lot of times it may not exactly be another PHP program that's going to come talk to this thing. We actually use JSON a lot of the time because that's something pretty much everything speaks if you need to represent something complicated. So we'll stick JSON in there and know that whatever we're getting out of it can get JSON out. So that's kind of like the difference in the model, right? We were going to do this anyway. So really we're just adding one line of code here to stick our thing into Redis as well. So when you have a schema like that where you have a table full of items and another table full of all the data about them that could be varying different types and lengths, the more you have, the less MySQL is happy about this. Even if you have indexes, that's not going to solve it if you have 10 million rows to deal with. The other problem is MySQL is really unhappy if you insert things into this table all the time and change it, because every time you change it, MySQL is doing its best to cache this for you, but every time you change it, that cache is blown away. So we have content producers publishing offers and publishing stores and all these changing the attributes on offers. So we can't really rely on MySQL to do the right thing for us, because people behind it are subverting that at every step of the way. So if you have data that changes a lot, now yes, you do have to go update it in Redis as well, but that is, like I said, it's basically free compared to doing it in a database. And it's a lot nicer because you can have a much more consistent experience. Whereas 2 o'clock in the morning, no one's been working on your content management system, it's fast. Whereas if you're not doing something like this, 12 o'clock or 2 o'clock in the afternoon where you've got 5 people working your content management system, that cache is getting blown away all the time. Every time that table changes, MySQL's query cache is dead and it has to do it over again. Whereas this keeps it in memory ready to go at a moment's notice all the time, no matter what. One of the other things we do with this is session clustering. Redis is great at session clustering. So if you have a lot of web servers that serve the same website, you can't really store PHP sessions by default just the way they work, because it puts them on the hard drive. So if a user gets on this one for page 1 and this one for page 2, their session information isn't carried over between those because you don't know what server they're going to go to, right? If you're moderately successful at what you're doing, you have this problem. There's lots of different ways to solve it. Pretty much every framework for PHP offers you this solution, which is store your sessions in a database, right? You've got lots of web servers, but you don't have very many database servers, and sometimes you just have one, or maybe one, and then they're slave to replicate to. So let's just put them in the database, because no matter which one of these you go to, you're talking to a consistent data set behind it. This is another one of those problems where the more successful you are, the less this works for you. The other problem is if you have...
Yet we endure, so...
What's that?
Yet we still endure with that problem.
We do, yes. And it's not the end of the world. And like I said, it's step 1 in solving this problem. But if you have, so let's say you have, this goes to 7, which means you need 2 database servers or 3 database servers. Well, now you have potential for the same problem in that, are you really 100% sure that the change that happened on one database server has manifested itself on all the other ones, right? You end up creating the same problem for yourself over again. One of the nice things you can do with Redis is you can offload your sessions into Redis. We have probably, in one of our Redis instances, about 2 gigs of its memory is the PHP session data. Rediska comes with a session handler built in, so you can just tell PHP to use Rediska's session handler and you're done. Redis doesn't have that, but it's pretty trivial to write one, and I think one of the code examples is how to write one. I'm not really sure why it hasn't made it back into the library itself. But so now you've got your data set over here, you're fine, you don't care about offers and items and everything, you're just talking about sessions. This can store your PHP sessions right in memory. They're really fast, right? It's faster than even the default, because the default is writing it to a hard drive every time. This is in memory. This means that sessions now, you can have a whole bunch of crap in your session and it doesn't really affect you that much, because as long as you've got the RAM to do it, you're fine and it's going to be really fast, and the session now is not really part of your overhead anymore. And the way you scale up Redis, it's kind of a sharding approach, so you're less likely to have this database replication problem. You can get there, but the overhead of Redis is so low that, worst case scenario, then I would just probably get a special Redis that does nothing but my PHP sessions, and I'd have to be really big before that became a problem. I'm not going to go into code for this because it's really boring.
But I missed the part where you have the Redis. How do you combine 3 web servers to one Redis?
So, you know, just the same way you have 3 web servers, they all connect to one database.
Right.
You know, as a user comes into your website, you make a connection to Redis and get the stuff out you want.
But where is Redis? Is it on a different box? Is it on every box?
You probably want to run one, or you know, you have one database. We actually run in a lot of our stuff. We'll get one database server that's got a crap load of RAM in it, and we'll give half to Redis and half to MySQL. Usually the stuff we do to MySQL doesn't all fit in memory. MySQL isn't a huge memory issue for us. It's more of a CPU I/O, disk I/O sort of thing. Whereas Redis is sitting in the background using 8 gigs of RAM, and it's just puttering along using 2% CPU usage to talk to memory back and forth. So a lot of times we'll start with putting Redis on the same hardware as our database server, but it is a fully separate process that things make a separate network connection to.
I didn't hear you cover logging earlier. Does it actually generate some logs?
Yeah, it does. It generates a binary log, and you can have it generate like a text log that you can take a look at as far as clients connecting and that sort of thing. But you can, from a I want my data sort of log, they have a append-only log file that they do for that. That's not on by default, but you can turn it on. And then if you actually want kind of the activity log, you can do that as well. And you can actually also, from the command line tool, you can see your kind of stats as far as data transfer and how many bytes is it using, how many keys is it using, all that sort of stuff. You can get a bunch of information as far as how it's doing from the command line tool.
Yeah, I was thinking like have a log adapter on it and do a correlation of 2 different processes to see if it's happening. I don't know if you need that sort of thing. You did say earlier it's not 100% reliable.
It's, for all intents and purposes, it's 100% reliable. I mean, there's always going to be the edge case, but given that it's an in-memory piece of software, it's not like Memcache where if you turn the server off, it's all gone, right? It is actually logging to its data file so that when it comes back up, it can read the data file and it basically looks at, okay, here's what's in my Redis database, copy all of this back into memory before you start serving requests again. So it does a pretty decent job of taking care of itself, and you can adjust a lot of those settings for like how often does it take new writes that it gets from memory and store them to disk. If you're very, very concerned about the data, you can turn those settings way up so that it does it almost immediately, every 10 milliseconds or something. Or if you're less concerned and you're more concerned about performance, you can have more stuff in memory floating around before it decides to sync those down to the hard drive to make sure that you don't lose them. So you can kind of pick whichever one's more important to you, and you can tune quite a bit of settings around how it deals with that. So Redis makes great job queues, and job queues are great for, I've got this complicated thing, and I can't afford to do this during one web request. I need to put it off into the background somewhere, right? I need to, and this goes against what I said earlier, but this is the example that comes to mind. I need to process a credit card in the background. I don't think I would do that with it, but I'm doing some complex thing for someone. I need to put it in the background and figure it out later, and I'll come back to it, right? That's kind of what your job queue is, right? For offers.com, the thing we do in the background is take all of the behavioral data that comes in about what people do on our website. We just stick all those into jobs, put them into Redis, put them into the job queue, deal with them later. I don't want to do all the database writing and key checking and everything while the web request is going on. I don't want to burden the user with my need for data and what they're doing, right? I just want them to do it. I want to record it as fast as I can to make sure that me recording what's happening isn't actually changing the experience for people. That's my use case for it. So we talked about those lists that Redis has where you can operate like a queue on either end of the list. So since it allows me to do blocking I/O with that, I can actually wait for it, and I can write a long-running process that just sits there in the background and spins through these keys as they show up. And I've actually got code that does that. I'll show it to you. Is that big enough? Maybe I can make that bigger. So I wrote a little class. I'm requiring, I've made a far out of Redis. Like I said, you can get it like that. So I just have this one file sitting in a folder that I can include and I'm all set. So I made a job queue class, right? And I'm using, I've got push and pop on my queue, and I'm basically proxying those right down to a Redis command to work on the database like that. So for my queue, I take in a name, what I want to call this job queue particularly, and then I'll set up a Redis client. Now this is a lot like connecting to MySQL or any other database. If I wasn't on localhost, I would need like a host array of options like host name and database name and things like that. This is just the default it's running on my laptop. I don't need any of those extra options there. So the meat of this is push and pop. So basically what I'm doing is I'm using the name of my job queue as the key in Redis. So I have one key that represents my jobs. And again, unless I get to billions of jobs, I can put all of these jobs in one key no matter how many I get. I'm just serializing it. I'm assuming that it's some sort of PHP array of stuff to do later, pieces of data. You can have Redis serialize them for you, but that's some extra configuration I don't really want to get into. Because I usually try and store just plain text, plain raw data in Redis, because it's nicer to read on the command line, but it's nicer to work with for other programs later. So sets have commands like push and pop as well. Right? So I can put in things into my set, and it's kind of got a nice explanation here of how exactly that works. L push is push something on the left-hand side of your set, right? And R push is push something on the right-hand side of your set. And then you can pop off either side as well if you want to. So you're working from the ends of these things. So what I'm doing in my code is taking these and I'm pushing onto one end and popping off the other end. So it's first in, first out. So when I want to push something into my job queue for PHP, I go get my job queue class and I say, hey, push on a new job. And I'm telling it that a job is going to be an array of some sort. Something in there is going to be an array. I don't really care too much about what is in there because I'm assuming I've checked that somewhere else. Here, so I've got another process that's going to come along and use this same class and pop jobs off the other end to actually do something with them. In my case, it's take data and write it to all the different places and log it, all the different places that we want to log it. I wrote a different option in here to block, right? So if I don't block, what's going to happen is if I run a script to go process keys out of here, it's going to go and I've got a loop and it's going to keep going until there's no more keys and then like my script ends, right? PHP stops running. I can if I tell it to block, when Redis goes and asks for the next key, if there's not one in there, Redis is going to sit there and wait. So I can actually have a PHP script that I run in the background that will run essentially forever. That will just keep waiting for more jobs to come, right? And the way I get it to run forever, within reason, is it's just going to sit, Redis is going to block it, and it's just going to sit there and wait until something else happens. It'll process a job, wait 10 minutes, another one comes in, it'll process that, and it just keeps on going in basically an infinite loop. The difference here is I've basically got rpop and brpop, right? Rpop is pop something off the right-hand side of my list, and if I want to block, the command is brpop. And this is another example. If you go back to that redis.io page of the big grid of commands that you can do here, Redis is doing something nice and just basically saying all these things, these are methods that you can call on me. And it translates that in the background to do the right thing in Redis for you. If you are inclined, you can say Redis execute command and type in the actual thing you would type on the command line, and it does the same thing. This is just a convenience method that Redis provides for you. And I can also give it a timeout, right? I want you to block and wait for new jobs, but if nothing comes in 30 minutes, then give up and try again So basically, simply stick stuff into Redis into one set, pull it back out. So actually some code that uses this. I'm giving it test queue as its name when I construct it, right? So that's going to give me a key in Redis called test queue. And when I add stuff to it, that's going to make it a set, right? So it's going to make that key of a set kind. And I'm going to start putting stuff in that set. All I've done here is just put random numbers in it, right? I'm creating an array, right? Because I told my job queue up there that I expect an array. I'm just creating an array with number and random. Just junk data to put in here. Put 1,000 of them in there. All right, so I can say tell my job queue to push 1,000 jobs in of crap. And then here, this is my kind of infinite loop, right? As long as there's a job to be had, we'll just print it out to the command line for this, but do something groundbreaking here. So that'll just loop forever, but waiting on Redis to tell it that there's a new key in that set that's ready to be processed. If I tell it not to, right here I'm telling it actually not to block, so it will finish when it's done with 1,000. If I tell it to block, once it gets done with 1,000, it will just wait for number 100,000 or 1,001. So,
you just keep it running. Like just as an example, when you're looking for processing this user navigation data or
yep.
whatever. So how long do you have to wait there before you have to trigger it with a cron job or something?
So we actually use Monit. So we have a thing that tells it it's running or not. So it'll check, is the thing that processes this job running? And assumingly there's not a fatal error or something in PHP that kills it, it's going to keep running, right? I mean, our uptime on those processes was weeks, usually. So we have one PHP that's running for weeks doing that. And it's third-party software that as soon as it detects that something bad happened and it's no longer running, start it back up again and let it run again. So basically 24/7, there's something sitting there connected to that, waiting.
What was that monitoring program?
Monit.
Monit?
M-O-N-I-T. Very cool stuff.
Okay.
So right now there's nothing there in my test queue set. So if we come over here, so we scroll back up. So the thing I did with no output was insert 1,000 random number of jobs in here, right? And then the next thing I did in my script was basically as long as it can pop a job off my job queue, print it out to the screen. So, you know, put 1,000 things in there and then pretty darn quickly process 1,000 through them, right? Now normally the use case here is it isn't on the same file. It's two different things running in two different places. One of these is my website putting stuff in on one end, and the other one is something on a server in the closet somewhere pulling them out on the other end.
What does the connection configuration look like?
So for local hosts, it's just new Redis client. Usually, you put this behind a firewall somewhere and don't expose it to the internet, so it's new Redis client with a host name. You can authenticate, but I've never seen anyone actually do that. It's one of those things you just keep it behind your network somewhere and connect to it by IP address. So this, we came back to the command line prompt here because it finished those 1,000 jobs and then ended the script. If I change this to true, block.
Do like 10.
10?
Yeah.
Okay. 10 jobs?
Yeah.
Right? So now I'm waiting for something else to happen here. Right? So we can come over here, right? It is empty again, right? Because my script has emptied all this set out. So now I can do, I will try and do S add again, although apparently I was failing at that. So let's do output, is that what I'm doing here? You have to pay attention to this because I could do the same exact thing and swap the left and right, and it would still be the same as long as I keep going from the opposite end. They'll push. There's no way I can serialize PHP in my head. So, but anyway, so like if I have some other process, I can go put something in there, and this guy who is still running, no, it's not. Connection profile, and by default it does time out eventually. So basically, this guy we have this guy just sit and wait until stuff happens. Again, this is, you don't have to do that with lists. You can do something completely different with lists. That's one thing that we do with lists to keep track of jobs. That did time out eventually because by default, Redis, not Redis, but Redis, the library, is trying to help you not do something silly and leave a connection open for years. We just turned that off. Yeah.
I noticed that you didn't set the execution time. Does that actually work without it being set?
On a command line, it's not enforced.
Oh, on the command line, right.
Yeah. I believe we got one more. This is the other one that we do all the time. So we have a 3,900 retail store and merchants that we sell stuff for. And product team came in and said, users like to see offers.com/Sears. They don't want to see offers.com/store/ID/47, right? That's what we want to do because that's easy and that's built into the framework. But users don't like that. They want to. One person asserted to me that users will know that they can type offers.com/Sears, and I said php.net/whatever. Yes, programmers will know that. I don't think users will know that they can type that in, but whatever. So the problem that this causes for us is basically we now have to program how to match these URLs. So by default, there's nothing about that URL that tells me that that's a store page, right? What if I have offers.com/privacy policy? How do I know the difference that that's a not a static page and it's actually this dynamic page? It should be loaded based on something in the database. So I go look it up on the database. I say, hey, if my URL has 2 slashes in it, if it's one level deep, I need to check to see if it's a store. So we write a route for that. And we use Zen Framework, so we kind of plug in something that looks like this into Zen Framework. So select ID and type from stores where the URL matches, right? If this comes back with something, we know we've got a store page and we should send them to the code that gives them back a store page. If nothing happens, then we know we should move on with our lives and it wasn't actually a store page. If someone types offers.com/I don't know what I'm looking for, we need to know that that's not actually a store page because it doesn't match anything in the database, right? It is a 404. So that means that for every single page request for a top-level directory, I have to do a database query, at least one, no matter what, to check if it's a store page, right? So I have some code here that goes and queries the database, and if it is a store page, I tell Zen Framework, module, controller, action, where do you actually go to if you see a URL that looks like this? And then the next week, we need to have holidays at the top level. Offers.com/Christmas, right? So now we have this problem of, okay, now slippery slope, everything needs to be at the top level because those are pretty URLs. And these are all in different database tables in different places, and the rules for is it a holiday are slightly different from is it a store. And so now every single page request for a top level directory, I have 2 database queries that I have to run. Worst case scenario. If I find a store, I won't find a holiday unless there's a store named Christmas, and then I'm really screwed. And then now everything becomes top level directories. So now every single page request, how many tables do I have to query to go find out what the hell to show to somebody, right? So we took this and we denormalized it into Redis. We use hashes in Redis for this, right? Because what I really want is that. I want a nice associative array back of the different pieces of data that I need to give to my framework to route. So I can ask Redis, does this key exist? And the key that I use here is the URL, right? Because that's what I want to look up by. I know I will have a URL in my hand when I go to do this. So I'll make the key name /Sears, slash, right? I'll know that. And then what I'll do is I'll take that and make the different pieces of that the actual data that I need. So I'll look up my URL and then I'll get back the important information. So I look up my URL and I can do hget, which is get something out of a hash, right? Get the module, get the controller, get the action. And I'm looking up, again, the key that I'm looking up for each one of these is the URL. And I just stick this back into the array that I'm looking for. The nice thing about this is I can use this for everything, right? Notice the first one I have is named store route, right? And I might have one slightly different with different database query, different logic for holidays, and another one for themes, another one, usernames, right? So this.
So question, since you're doing this for optimizing, why not just put it in one big string instead of doing 3 round trips using the hash?
So, we do. Actually, that's a great question. I'm glad you asked. We actually do.
Set up.
I did this to kind of show more getting stuff out of the hash. There's actually one called hgetAll, which gives you everything back in one call. We do that. The downside to getting everything out of the hash at once is that you just kind of get a list of them. You don't really get the key names back. Let me see if I can show you one of those. So here's one, right? This is a new one we added, local pages, offers.com/Cleveland. So we can do hget, that guy, not called action, maybe I'll be called action. Right, I get back something like this. I've got module, local, controller, city, action, index, right? All my information. That is not great, but if you know what format it's going to be in, it's fine. And it does save you the 3 queries, although that's probably pushing optimization. You're talking about saving yourself maybe like 10 milliseconds. The other neat thing that we're not going to talk about that Redis lets you do is you can pipeline commands. So if you know you want to add and change a bunch of things, kind of like, almost like a transaction in a relational database, you can kind of queue all those up and then burst them across to Redis at once. And Redis has a function called pipeline, and you can pass it a PHP 5.3 closure of all the things you want to do. It's really slick. Where are we at? Who wrote this program? So now, every time someone comes to me and says, I want another top-level directory thing, all I need to do is write the thing to fill in the keys, and this one piece of code will route everything on the website. It can check any sort of thing, because what I'm storing in the key is what do I actually want to do for that page. So the one thing we had to add is, when we create a new store, like I said before, when we create a new item, we might add something to Redis. When we create a new store, we'll stick its routing data into Redis as well. Right, so we upload a new store to the website. We'll stick in a key with these things into Redis so that it will show up. Until we do this, since we're reliant on this now, it's not going to find a store for that page because I'm not looking in the database anymore. HMSet, multi-set for a hash, lets you basically take an array like this and sets all this stuff up so you don't have to do setting each little bit one by one. You can set an array and it will stick it all in there for you. And again, this is O to the n time to do this, right? However many things you have is how long it takes. It doesn't get any longer or shorter based on, this being an array with 10,000 items or an array with 1 item. So that's another thing that we've done to basically just speed up the routing on that, both from a complexity standpoint, so I don't have to have 30 different pieces of code to maintain, and then the code that I do want to maintain with that logic in it isn't in my routing code, it's in the actual object itself with the thing that it goes with. And also it doesn't matter how many of these things we have now, it's constant time for me to know if this page exists or not, because I can just go ask Redis, is this a page or not? And we're done. I don't have to ask it, is it a holiday page? Is it a store page? Is it a privacy policy, right? It's all just there, and I know in one time, is it good or not? So, general idea, right? So, that probably just went above everybody's head. You know, you're like, okay, this sounds cool, but not all that exciting. It's just a database. Now, it's definitely check out their documentation. They've got a great set of example code of things you might want to do with it. Unfortunately, the you know, S-Interstore isn't particularly descriptive of what it does. But a lot of these ones where you can't make out what it does, those are the really powerful ones, unfortunately. You know, a lot of this stuff, the way that it's implemented, because of it's really quick from a programmatic execution standpoint, doing something that you would normally do in lots of lines of SQL or application code, this can just do it for you on the server side, and it's done, and it's faster than you can write it. I mean, at least as fast as you can write it elsewhere. The other neat thing that I realize now wasn't immediately apparent when I was talking is a lot of these things mean that you don't have to write code to pull it out of the database, do something with it, and put it back into the database. If you want to take, you know, one of the other ones we do is blog comments, right? So I know it's easy to go find out how many blog comments I have, but on an archive page, I've got to go do that for every single post that shows up, right? So we just keep a key of how many comments does this blog post ID have. And it costs us nothing to go look up what that number is, right? So when I actually want to write code to go put a new blog comment in, I don't have to say, you know, get the number out of Redis, say blog comments equals blog comments plus 1, save it back to Redis. I can tell Redis just to increment that key by 1, and I'm done, right? I just told the server, take whatever value you have and increment it, and the server did it for me. I didn't actually have to do a data transfer there and write the code to increment it. And there's a lot of commands like that where you can actually just do something to manipulate your data like you can with SQL, and you can do it on the server. You don't have to write application code, which is actually quite a bit different than you'll see with something like MongoDB or CouchDB, where you're having to write application code to do this stuff for you. So that said, any questions, anything that I glossed over, anything that...
I have comments.
Yeah.
Okay, so, application. I'm actually surprised you didn't mention this. Languages, right? You connect with the client, I'll pick up a language you're speaking in. Could have a map with the words that would match up with the words in the context and replace them as it goes. Now, of course, it wouldn't be like a whole sentence, it would be like a menu, would be translated and so on. Because I don't have to query the database for the name, I'll just use that to bring the map value for that word.
Mm-hmm.
There is web services that provide a cloud for subscribers of supply chain management, like a hard drive. Dell orders, so they put out a forecast in the cloud to say we need 100,000 hard drives. And somebody that subscribes to the cloud, you know, would now respond and say, well, we can provide 60,000, but they would be in Japan, like Sony, whatever. You have Gateway, and then it's in Germany, whatever. There, you would have an inventory of every single one of these items once it comes through, and then this here would prevent the lookup not only of the inventory, but also of the languages, the language mapping, so that the guy in Japan would see their inventory in Japanese and so on. So here, I would offload all of that language stuff to this, right?
Yeah, I mean, we that's actually, like you said, offload 2 or 3 times in there, and that's really like one of the key concepts is like offload it, right? You don't want to use this as your primary source.
I get the database because we always deal with problems with the database.
Yeah.
Right? Queries, we're always looking, how long did the query take, can we index it, and so on. Well, here I would say, well, forget about that, just use this.
Yeah. Yeah, and that's one of the, you know, we'll do a code review on a new feature, and someone's like, well, yeah, it's great, it works perfectly, but it adds, you know, 1/10 of a second to our page load. I'm like, okay, put in Redis, we're done. Problem solved, right? We actually have a pretty slick piece of code that we just attach to our models, and any model call we have, it'll take it and put it in Redis and cache it. Doesn't matter what it does. It can be database related. It can be like intensive processing. It's almost like that function call. We can just stick it in Redis. Actually, I'll pull up the GitHub page for that because it's one of my engineers wrote it, and it's really cool stuff. Basically means like if there's anything really complicated and that function takes a long time to run, we can put underscore Redis in front of it, and now it's cached in Redis. Right. So the next time it's called, unless something's expired, it just doesn't even call that function. It says, hey, you were to call this function translate language, and you were going to give it these arguments. Well, I already know what the answer to that is. It's in Redis. I'm going to go get it out of there. And you don't even have to worry about running it again because I already know what the answer is. And we've hooked that up to a lot of different things because once we got through this level, we were like, okay, this is getting really tedious because now we're not writing SQL, but we're like writing Redis code for everything, connecting to Redis for everything, and writing bespoke little features to solve little things here and there. Why don't we just do it at the system level? Why don't we make everything connected to Redis and make it smart so hire a new guy, like, hey, just put an underscore Redis in front of that and you're done. I'll actually pull it up at the end here. But yeah, absolutely. Anything that you can offload to this, it's going to be faster. A lot faster, especially the, database scaling sucks. Scaling this is pretty easy.
Not only that, the database does its thing until it returns the data. The user is waiting, right?
Yeah.
You could provide content while that's happening in the background.
Yeah. Yeah, I mean, we have offers.com/Christmas as an example. We didn't want our content producers to have to go through 18,000 offers, and that's total, but there's thousands a day that cycle through and say, is this a Christmas offer? Is this a Christmas offer? That one might be a Christmas offer. And then come to like December 12th, everything's a Christmas offer. It doesn't matter if it's for something that happened like 6 months ago. If it's on sale, it's for Christmas, right? So we didn't want them not to do that. So we have this really, really, really complicated SQL script that will figure out, based on all this other stuff, what should go on the Christmas page. It takes like 4 seconds to run, right? We can't have somebody waiting 4 seconds for content on our live website. So once we run it once, we just stick it in Redis. We stick a set with all of our offer IDs in there that go on the page, and I can go really quickly get the offers out that I want and not have to do that big calculation, but once or twice a day. And I still have the SQL code because my content management system talks to SQL database. But I offload so much of my website front end into this now because it's so fast and it's so much, you have to spend less time worrying about, is it fast enough? How do I tune this? How do I use my indexes to make this query faster?
So you're comparing this to Memcache. Usually a Memcache starts with how you can set up this mesh and use RAM on each of your web servers to spread the data around, but you're just sticking it all in one place.
Yeah, so Memcache is a cache. And I'm using Redis like a cache in a lot of places, but Redis is a database. And so I'm treating it like a database where I have, one of them behind the scenes that's storing the information. You can definitely do that with Redis. You can shard it and do consistent hashing to decide which server it should go into. And if you're, Reddit or Facebook or something, you've got these sorts of problems. We found that, a Redis server with 16 gigs of RAM, which is like a $2,000 web server these days, that solves a lot of problems, right? That solves way more problems than we'll ever have. I hope someday we're successful enough to need another Redis server. Cool, thank you guys. I know a couple weeks ago I said that we weren't hiring, and now we are again. So we save people money. That's what my company does. We have offers.com, which is our flagship property, dailydeals.com, which is more kind of the Groupon model for things, couponcodes.com, which we recently launched, and subscription.com, which is one of our older sites that's obviously not subscriptions, but it discounts on all subscriptions. All these are PHP apps. All of them are on Zen Framework. So if you're interested in working on that and you live in Austin and you'd like to come work on Redis and PHP and other really cool stuff on a daily basis, we are looking for engineers for all of these properties. So shoot me an email, shoot me your resume, and we'll talk. Thank you.